dawn. The daily cycle of the sun begins on Earth's eastern horizon. Each day, the sun's light penetrates the darkness as it has for eons. But during this limitless span of time, man has evolved from the primordial state to the sophisticated technology of spaceflight. And at Cape Canaveral Air Force Station, Florida, the United States Air Force has established an unusual museum, one which has permanently preserved with actual space hardware a history of rocketry leading to man's venture into space. Through the past decades, a trailway to the stars has been blazed by hundreds of major launches from Cape Canaveral. These were the great moments in space history. And at the Air Force Space Museum, the memories of these milestone events are preserved for posterity. The museum grounds, which include the launch sites for America's first satellite and first astronaut, are home for a unique display of missiles and rockets, some rare and forgotten. Nearly 250,000 people visit the museum annually to see the free world's largest display of space hardware. Many visitors ride through the grounds on daily commercial bus tours. On Sundays, visitors are allowed to drive their own cars to the museum, which is open to the public free of charge. Public figures such as Prince Philip of Great Britain are among the many distinguished visitors. People from all walks of life and from all over the world marvel at the rare collection of space vehicles. At the museum's exhibit hall, colorful and informative displays await the visitor. Scale models of rockets, old and new. Even an actual Gemini spacecraft, the only one flown into space twice, can be closely examined. An art gallery within the hall depicts the history of rocketry, reflecting in color and shading the flesh and blood human experiences leading to space. That story begins with the primitive skyrockets used by the ancient Chinese over 2,000 years ago. These arrows of fire were used to chase away demons and to please the gods. The first significant use of military rockets took place at the siege of Fort McHenry in 1812. British rockets hurled explosive warheads to targets 1.5 miles away, an event which inspired the phrase, "the rocket's red glare," in our national anthem. During World War I, rockets mounted on French pursuit planes were effectively used to destroy enemy observation balloons. One of the key developments in space history began with Dr. Robert H. Goddard, a physics professor often referred to as the father of modern rocketry. In 1926, at Auburn, Massachusetts, he created and fired the world's first liquid-fueled rocket. It rose to an altitude of 184 feet in 2.5 seconds. Eventually, Dr. Goddard's propulsion system would take men and machines to the very surface of the moon. During World War II, German scientists developed a potent weapon, the liquid-fueled V-2 rocket. V-2s, armed with high explosive warheads, rained heavy destruction on Great Britain. This demonstration of power suddenly awakened the military and scientific communities to the potential of rocketry. After the war, V-2 rockets and German scientists arrived at White Sands, New Mexico, where an American program of research and development was started. As the program expanded, a larger and better situated launch area and range was needed. The choice was Cape Canaveral, a narrow strip of Florida marshland facing a 5,000-mile stretch of uninterrupted Atlantic Ocean. On July 24th, 1950, Bumper, a modified V-2, became the first rocket to be fired from the Cape. With this successful launch, a new era in rocketry began. Missile test programs with strange-sounding names soon crowded Cape Canaveral's launch schedule. Matador, an Air Force winged missile, launched from a mobile platform. It flew at subsonic speed and had limited range. Snark, the first missile designed to have intercontinental range. Redstone, a U.S. Army short-range ballistic missile. Redstones would eventually boost America's first satellite and first astronaut into space. As testing increased, a national commitment to future rocket programs was demonstrated by the construction of new facilities. A Center for Control of Range Safety, Instrumentation, and Scheduling. Larger launch pads and advanced electronics to record the rocket's flight for later analysis. This was Navajo, a winged jet rocket-boosted system designed for a 5,000-mile range at supersonic speed. Despite the resemblance to today's successful space shuttle, Navajo was plagued with difficulties. It did, however, provide answers to many technical questions about propulsion and guidance. Testing progressed, much was learned even from its dismal failures. Knowledge gained from Navajo was a factor in the success of Jupiter, a U.S. Army intermediate-range ballistic missile. Jupiter helped solve the problem of nose cone re-entry into the atmosphere from space. The Air Force Thor, another intermediate-range ballistic missile. A rocket which performed so consistently that it continues to be used by NASA as the standard booster for many of its satellite launches. But even as we made progress in rocketry, so did the Soviet Union. In October 1957, the Soviets captured world attention with the launch of Sputnik 1, a 184-pound satellite which circled the Earth every 96 minutes. Spurred by this achievement, the U.S. Navy hurriedly attempted to launch a Vanguard satellite from the Cape in December 1957. It failed after only 2 seconds of thrust. Reaction to this failure was swift. An earlier rejected plan by the Army's General George Medeiros and Dr. Werner von Braun was quickly put into motion. A modified Redstone called Jupiter C was prepared for the launch of America's first space satellite from Pad 26, now the site of the Air Force Space Museum. On this historic occasion, a dedicated launch team headed by Dr. Kurt Davis completed the countdown. On January 31st, 1958, the tiny 31-pound Explorer-1 satellite rose into the night sky. 98 minutes later, orbit was confirmed, and the first step of American space exploration was accomplished. Progress in rocketry moved rapidly in another direction as a response to the growing threat of nuclear aggression. In 1957, the U.S. Navy fired the first Polaris missile from a submerged nuclear submarine. Advances in the development of solid-fueled rocket motors gave America the potent Minuteman intercontinental ballistic missile.
Stand fog and deluge disabled. Disable. Cage gyros and gyro heaters on.
Launched from a protected underground silo, the Minuteman is capable of carrying multiple nuclear warheads which can seek targets half a world away. One of the more significant developments in American rocketry was the Atlas, an Air Force intercontinental ballistic missile. It has served the nation not only as a weapon system, but also as a reliable booster for an impressive number of space accomplishments. Finally, man himself was ready to venture into space. On May 5th, 1961, Commander Alan B. Shepard arrived at Launch Complex 5-6, now part of the museum grounds. Here, a Mercury Redstone rocket stood ready, fully fueled and checked out for America's first manned flight, a brief suborbital ride to an altitude of 115 miles.
Cameras and tape off. ECS free on off. Free on off. CO, control fuel. Roger, fire, watch the panel.
Automatic fuel is 95, manual is 96, cameras and tape recorders are running.
I have a cap.
8, 7, 6, 5, 4, 3, 2, 1, 0. Lift off. All right, lift off and the clock is started. This is Freedom 7. The fuel is go 1.2 G. Cabin at 14 psi.
Not a very startling flight record by today's standards, but it was a beginning, a pathway into space which would lead to man landing on the moon 8 short years later. On February 20th, 1962, an Atlas rocket launched astronaut John Glenn into America's first manned orbital flight.
Latest check pressurization. Rocks tanking. You are go. Water systems, go. Range operations. Mercury capsule, go. All pre-start panel lights are correct. The ready light is on. Eject Mercury umbilical. Oil evacuate. Mercury umbilical clear. 5, 4, 3.
Roger, backup clock is started.
Glenn's mission marked a milestone event in our space program. In 1964, an Atlas booster put a picture-taking Ranger spacecraft on the lunar surface and gave man his first close-up view of the moon's surface. Ranger was followed by the soft-landed Surveyor, which transmitted thousands of photographs and valuable lunar soil data. Later, a lunar orbiter circled the moon, pinpointing landing sites for the Apollo astronauts. A series of 10 manned Gemini Titan spaceflights, each with 2 astronauts aboard, developed maneuvering techniques needed for the Project Apollo moon journey. One of the most dramatic achievements of the Gemini series was the famous first walk in space by astronaut Ed White. Equally impressive was the rendezvous of Gemini 6 and 7. This was followed by the successful first docking with an orbiting Agena in the Gemini 8 mission.
10, 9, 8, ignition sequence start. Engine
Luminous orbiting
5,
satellite of
4,
Earth was
3,
now within
2,
man's reach.
1, all engines running. Launch commit. Liftoff. We have liftoff at 9.
On July 16, 1969, with the world as a witness, a huge Saturn V rocket with Apollo astronauts Neil Armstrong, Edward Aldrin Jr., and Michael Collins aboard roared skyward. Their flight began man's most daring adventure, a voyage to the moon. 4 days later, almost 250,000 miles away from Earth, man's age-old dream of landing on the moon was spectacularly fulfilled.
75 feet. Car's looking good. Down a half. 6 forward. Down 2.5. Forward. Forward. That's 40 feet. Down 2.5. Picking up some dust. 30 feet. 2.5 down. Straight shadow. 4 forward. 4 forward. Drift into the right a little. Down a half. Contact light. Okay, engine stop. Houston, Tranquility Base here. The Eagle has landed.
By the end of the Apollo project, 12 men had walked on the moon. In later missions, the range of their explorations had been extended by a lunar roving vehicle, the first manned transportation system to operate on the lunar surface. The Apollo astronauts explored 6 landing sites, each a different type of terrain, each yielding new information and discoveries. Among the hundreds of pounds of rock and soil samples collected and returned to Earth for analysis was a unique crystalline stone now called the Genesis rock. It's estimated to be 4 billion years old. Nuclear-powered LSEPs, Apollo Lunar Surface Experiment packages, were activated at 5 of the landing sites. Long after the last astronaut had departed, the LSEPs continued to report their scientifically important findings to Earth. Project Apollo was a huge step forward in man's understanding of the moon, the Earth, and the universe. And yet, it was just the beginning. While Apollo was oriented toward long-term benefits to be reaped from deep space, Project Skylab concentrated on the more immediate advantages of placing men in near-Earth orbit. From May 1973 through February 1974, 9 astronauts in groups of 3 per mission lived a total of 171 days aboard the Skylab workshop, an orbiting scientific laboratory. Investigations and experiments performed by the Skylab astronauts produced scientific observations of quality and quantity never before possible on Earth. The missions provided the United States with information about prolonged exposure of men to life in space. We learned that man can live and work effectively in space for indefinite periods. The extended Skylab missions also provided opportunities for investigations and experiments which suggested uses of space far beyond anything thought of earlier. Photographic surveys suggested solutions to problems of Earth resource management. Experiments with manufacturing processes produced materials lighter and stronger than anything possible on Earth. Another major milestone, Skylab revealed exciting potentials for the use of man in space. International cooperation in manned space flight was demonstrated by Apollo-Soyuz, the last mission for American astronauts in the decade of the 70s. With precise timing, Thomas Stafford, Vance Brand, and Donald Slayton aboard an Apollo spacecraft caught and docked with the Russian Soyuz spacecraft. The cosmonauts welcomed the Americans. Crews as well as meals and souvenirs were exchanged and a number of experiments conducted, including satellite-relayed communications. Well before Apollo and Skylab, the Air Force was developing Titan III, a standard space launch system. Workhorse Titan III boosters placed tons of payloads in orbit. The dozens of satellites launched by Titan III vehicles have provided vital defense communications, nuclear test detection, and data for scientific research projects.
10, 9, 8, 7, 6, 5, 4, 3.
Water is indicated on.
1, 0.
Liftoff indication.
The versatile Titan III has served the nation with a wide variety of useful space missions. Titan Centaur vehicles launched 2 of NASA's Viking spacecraft in a spectacular space event which celebrated the nation's bicentennial, the landing of 2 scientific laboratories on the planet Mars. They sent back data about the composition of the soil and atmosphere, along with these clear photos of the red, rocky Martian surface. In 1978, Pioneer 1, the first of 2 spacecraft to orbit the planet Venus, penetrated the thick cloud layers of the Venusian atmosphere with powerful radar signals. The data indicates that Venus is pockmarked with craters, possibly active volcanoes, and great lava flows. 5 separate probes released from Pioneer 2 analyzed the thick cloud layers of Venus as they descended over different areas of the planet's surface, where temperatures soar to 900 degrees Fahrenheit. The probes collected a wide range of data, including temperatures, density, composition, and distribution of the Venusian atmosphere. In late summer of 1977, 2 Titan Centaur rockets roared into space within 16 days of each other. Their mission was to dispatch twin Voyager spacecraft to the outer solar system to explore the giant mysterious planets Jupiter and Saturn. After almost a 2-year journey through space, the Voyagers returned spectacular photographs of Jupiter and its 16 satellites during the flybys of the planet. The exploring Voyagers found Jupiter to be a whirling ball of liquid hydrogen, topped with a colorful atmosphere displaying a great red spot, twice the size of the Earth. Its 4 largest moons were captured in dazzling pictures. Io, the smallest and innermost of the 4, revealed 8 active volcanoes, with one spewing out gas and dust 150 miles above the surface. Next target for the 2 Voyagers was Saturn, with its mysterious and exquisite ring system. Both spacecraft acquired a wealth of data and photographs that revealed the complexity of Saturn's rings and moons. Seen from Earth as only dim points of light, the Voyagers showed the moon's distinctive shapes and sizes. 3 of them were new discoveries, bringing the known total of Saturn's moons to 15. The rings were found to be composed of countless low-density particles of ice and rock orbiting at progressive distances from the planet's cloud tops. On this mission, the Voyagers provided more knowledge about the ringed planet than had been learned in all previous history. Closer to Earth, during 6 years of suspended manned spaceflight, mid-1975 to early 1981, unmanned launches continued to dominate the schedule at the Eastern Space and Missile Center. Many commercial satellites were orbited by NASA with Delta and Atlas Centaur launch vehicles. These were the years of exploitation of space technology, when there was a literal harvest in the sky in the fields of communications, weather forecasting, bioscience, and Earth resources. The expanding technology in space has also been adapted for our nation's defense posture. The U.S. Army's Pershing II missile, mainstay for the defense of Western Europe. And the U.S. Navy's submarine-launched Trident missile, a critical strategic weapon capable of striking an enemy heartland from below the surface of the ocean. Even as America reached impressive goals in space with expendable rockets, a totally new manned space transportation system was developed. Space Shuttle, the world's first reusable spacecraft. Designed to do useful, productive tasks in space at reduced cost, the versatile shuttle is launched like a rocket. It orbits the Earth like a satellite, and then returns to Earth and lands like an aircraft. The shuttle orbiter has a 65,000-pound cargo capacity and can be fitted with a wide variety of payloads for each mission. It has routinely placed communications satellites into stationary orbit for both domestic and foreign users, as well as carrying payloads for the American military. The orbiter's design enables the flight crew to perform a variety of tasks in space, including retrieval and repair of satellites in orbit, and if necessary, return them to Earth. The shuttle's largest payload is Skylab, a joint venture between NASA and the European Space Agency. It occupies the entire cargo bay of the orbiter, and within its spacious interior, mission specialists conduct many scientific investigations in a variety of disciplines. The space shuttle meets today's needs in space by providing routine access to low Earth orbit, serving as a platform for Earth or space observations, deploying payloads into orbit, providing ample accommodations for up to 7 astronauts, and landing at designated runways for reservicing. Now an operational space transportation system, the shuttle is moving America forward to benefit from the superb potential offered by the final frontier of space. It is establishing the means for a more permanent presence in space, the dawn of a new age for mankind. The Air Force Space Museum at Cape Canaveral Air Force Station is open for all who want first-hand exposure to the exciting development of rockets and missiles throughout the past years. The rich history of the United States Air Force participation in America's space program can be seen at the museum, where an enduring record of milestones in space highlight the beginnings of man's journey to the stars.